Thank you, everybody. My name is Sep, and I'm from LA. A couple of years ago, I wrote this library called DeepDiff. Made it open source because I needed something like that. It got some momentum. People started using it. People contributed. I learned a lot from it, and here I am to share that journey with you. Things that I learned, mistakes I made, and what you can learn. Here's contact info, but I will show it later. So the title is Diff It to Dig It. Have you ever done git diff, looked at the lines that you added, removed, when you added it, and you learned something from your code? I argue that by diffing data, you can learn a lot about your data too. The same way that you can learn from your code by doing git diff. And let's hear, this is an example, a nested data structure. One thing is different in these two dictionaries. Who can say what is it? Right? So, that's the line that's different. Okay? And my goal was to write a library that can give you exactly the path and value of what changed. And here's an example. So root index 0, that guy friends 0, that guy friends 0, that guy friends 1. Name changed from Joe to John. How complicated. Well, so our goals here is to get to a result like this, and we try to do that on different types of objects, see what we can learn from it. Our objectives, diff nested objects, get the path and value of what has changed, and what if you have in situations you don't care about the order? Like you say, these two lists for me are the same. I don't care. Just tell me nothing is different. This is an edge case that we will be talking a lot, and you can learn a lot from it. It's not as simple that it might seem at first. All right. So how would you diff? The first thing that came to my mind was we have different object types in Python. Based on the type of object, we will choose a different strategy. Okay? So these are generally the types of objects. We have text strings, those are like strings, Unicode. We have numerics, integer, floats, sets, frozen sets. Mappings are what Python calls dictionary and default dictionary, ordered dictionary. And we have other iterables, list generators, deque, tuple. We will get to them. And finally, they are user-defined objects. These are classes that you define yourself, and we want to see how you can get the diff of your own objects. That's the last thing we're going to be talking about. All right, so we start with text strings. The simplest one, just like what we saw, Joe became John. How do we find it? It's very easy. You just say, OK, Joe became John. But what if you have many lines? And Python comes with a standard, in Python built-ins, there's something called difflib that shows you in very clear syntax, it's something that you're used to, something that you see in Git, etc., what has been changed. Here we have a new line, it's ice cream time. Now, what about numerics? Those are the easiest. You just say, use the minus operator. Okay, like you say 2 minus 3, that's easy. Sets. These are relatively easy too. You just say, again, use the minus operator. And for finding, for example, what are the common items between two sets, you can use this thing called intersection. I'll use it later, but here I don't need it. So it's very simple to find out what's different between set elements. Next are mappings. So when it comes to mappings, these are dictionaries. So for example, here we have common keys. We have common 1, common 2, and one key that's added. How do we go about finding out what has been added, what has been removed? So the idea that I came up with was we turn the keys of dictionary into 2 sets. We again deal with them as if how we did sets. Next is the common keys of dictionaries, because the keys can be common, but the values might not be. And simply we do this recursively. We go back and we do recursively find out these common keys, what values might have changed. And again, if those are dictionaries, we go down and down. Those are simple too. Next, we have iterables. Iterables in Python are like list generators, deque, tuple. The simplest case is when we don't care. We just keep them in the same order that they are. We just go one by one, say, okay, number item index 0, is it changed? No. Item index 1, is it changed? No. And here's a very simple example. Next case is, what if the length of list has changed? And Python comes with this thing called zip longest, which I recommend you look into it. So you all know what is zip. It grabs the two lists that you have, zips them together into a list of tuples. What does zip longest do for you is you can tell it, fill the missing values with some object, whatever object you want. In this case, I made a custom object called not found. So the result that you see here is the last item we have not found and 6. We understand that 6 was added, right? Because in the list T1, it did not exist. Now, if we want to consider order, which is still the case we are talking about, this is basically a function that I wrote, very simple. It goes, finds if an item was not found, it is either removed or added. And here we see the example, like number 3 is changed to number 5. The complicated case arises when you want to ignore order. How would you do that? You have two lists. You don't care about the order. Anybody? Sets, yes. All right. So you use sets. This is simple. Now, there are times that you cannot convert a list into a set. And here we have an example. It says type error, unhashable type dictionary. So what does this mean? Let's first think about what are sets. Sets are unordered collection of distinct hashable objects. Your objects need to be hashable. Dictionaries are not hashable. And in order to understand this, I know a lot of people confuse hashable versus unhashable and mutable versus immutable. I want to give you some examples so you don't confuse these two. We get back to how we can use this to ignore order when we define lists. Okay, let's start with mutable versus immutable. In Python, a mutable object, when you modify the ID of object, it stays the same. So here you can see that list A, we appended number 3 to it, and it is still, it has the same ID. But the tuple, we added number 3 to it. It has a different ID. It's a new object. That's why it's immutable, because the ID changes. It is a new object. But when it comes to hashable, in Python, for something to be hashable, you need to have $hash and $eq for equality. I don't want to get deep to this part, but I'm going to give you an example of how you compare unhashable versus mutable, because we're going to deal with this a lot. Okay, so here is a custom object. We have attribute A, it's class attribute. We get the hash of the object, okay? And we modify that attribute. We get the hash of object. The hash has not changed. Still, this object is hashable, but it's mutable. Okay? Usually, a lot of people think immutable means unhashable, or the other way. But here we have an object that you modified, the hash does not change. It's still hashable, but it is mutable. Okay? Now, let's get back to why we got here. We had a list, we wanted to convert it to set, but it failed because the dictionary was not hashable. It was unhashable. How do we make this so it works? Any ideas? All right, let's go and see how we would do this. So here is an example. We have two lists of dictionaries. And when I got to this problem when I was making deep diff, I was like, what if I sort the dictionaries, or the lists, and then go one by one, items are sorted, they're aligned, so I see what is added, what is removed. And here you can see the item index 0 and var are replaced in these two lists. Okay? If we sort them, they get aligned. And we can easily say, oh, item number 4, which is, well, in this case, 5, is added. Here's an example of implementation of this in Python 2. Okay? We zip through it, and we see what is added, what is removed. However, this fails in Python 3. So let me show you again. In Python 2, this perfectly works. We sorted a list of dictionary. It worked. It aligned the items. In Python 3, this fails. It's because Python 3's sort algorithm is different. So when I get to this problem, I was like, how can I tell Python how to sort a list of dictionaries? Has anybody heard of sort key? Who has ever used sort key here? All right, some people. So Python comes with this thing called sort key. You can think of it as these are hooks or representations of your object that you can tell the sort algorithm to use to move things around, compare them. Okay, so this is an example. You have a list of 3 tuples, and the sort basically takes a function, in this case lambda s, and from this, we get the index number 2. So basically we order these 3 items based on the last numbers in the tuple, and it works perfectly. Okay, so I was like, how can you use this to order a list of dictionary? And at this time, I came with an idea. What if you serialize the dictionary, which gives you a string, you get the hash of that serialization, and you use that to sort the 2 lists? And here's an example that works. Works both in Python 2 and 3. So let me repeat. This part is the main part. So you can tell the sort function, tell it how to sort by defining the sort key. In this case, we say, okay, grab the item from the list, JSON dump it, serialize it, and then create a hash from it, and use those hashes as those hooks to align items. Okay? And it works perfect. Now, what if your lists do not have the same length? Let's see if it works. Here's an example. As you can see, the last item, it works perfect. Anybody sees a problem with this algorithm? So let's repeat. It JSON dumps your items. It hashes that and uses the hash to move things around. Okay, to sort them. Let's look at another example. Okay, here's another example. We add an item. Here is a string A. And you never know if the hash of the item is going to be less or more than what it was before it. So in this case, by adding string A, things got disaligned or misaligned. You see, A is in front of 1, 1 is in front of 3, 3 in front of 4. And let me tell you, this was actually something that was in production. Thousands of people were using it. And so that basically tells you have to look at what you're using. Okay? It was passing the test cases. A lot of people were using it, but nobody has really looked at, oh, actually, there's something wrong with this. And somehow, I don't know, if somebody opened the ticket or I found it myself, fix it. So after I saw this, basically I was like, sorting was a bad idea because you never know. You can't align things exactly in front of each other, the same items in front of each other. So what was the next idea I had was, which was simpler, Now we know how to create the hash of item. What if we make hash tables? So we will have two hash tables. We basically convert our lists or iterables into two dictionaries this way. And we know how to diff dictionaries. So the problem will be solved. Let's see what we can learn from this. All right, here's an implementation. Okay, so basically we have the same two lists that we just talked about. We get the hash of each item one by one. If we fail, then we do what we did before. We JSON dump the item, we get the hash, and voila, we add it to our hash table. And just in case something fails, in order to make the rock solid code, we just pass it. Well, this is for presentation. In reality, you don't do that ever. Don't ever do this. Okay, this is important. But here I didn't have a space to put what I was gonna say. All right. So with this method, now we create these hash tables, and we can see it works perfect. Okay. So what did we learn so far? We learned in order to ignore order is one of those cases that actually causes a lot of trouble. At first it seems simple. We tried to create set from it. Didn't work. We tried to sort. It was a bad idea. We created hash table. And how we did hash table, iterated over each item, tried to hash. If failed, serialize it into JSON, and then try to hash again. And we created the hash table. Okay, now we get to more interesting cases. What if object is not JSON serializable? What if the serialization, the JSON serialization of two objects are the same? This happens a lot. Like decimals are not JSON serializable. You can easily have objects that have the same serialization in JSON, but they are not the same. Or many objects that are not JSON serializable. How many people here use Django? All right, yeah. So Django objects are not JSON serializable. So you could not have used this system. Okay. What I thought after that was, what if I use Pickle? It's not safe, but I'm not sending this data anywhere. Pickle, generally, you should try to avoid it unless you really need it. That's my personal opinion. Because you can actually put code in it and it gets eval. It actually gets executed. So in this case, all I did was, instead of using JSON serialization, I used Pickle. Okay, so you don't have to look through this whole list of numbers, but this is an example of how Pickle looks. These are exactly the same objects, okay? And their pickles are the same. Just want you to look at it very carefully. And Python comes with this thing called cpickle. It's faster. Usually when there's a C library, you want to use that. I thought about using cpickle. Do you see anything has changed? Cpickle does not give you the same serialization for the same objects. Okay, let me go back here again. Pickle gives you the same serialization. These two objects are the same. Cpickle does not give you the same serialization. What does that mean? It means the hash of the serialization is going to be different because the serializations are different. And this is something you should keep in mind. Maybe you are some use cases that you want the serialization to be consistent. Cpickle does not give you that. And why? Because cpickle tries to optimize a lot for you. It keeps the references to the object. So if you have a couple of number of the same object, it actually tries to optimize, make it shorter. It doesn't repeat. But in our case, it actually messes things up. All right, so far what we have learned from iterables, here's a list, but your mind is fresh. I'm going to move forward. Next things are user-defined objects. Okay? So when you create your own class, normally it comes with this thing called dict, under dict. Okay? That's where the instance attributes exist. What does that mean? here we have an example. Here we have our own class. We have attribute 1, which is a class attribute. Okay? We have self.thing, that's instance attribute. Okay? And we get object 1 under dict. We have the instance attribute. Why do you think in object 2, which is from the same class, we have attribute 1, but object 1 we don't? Anybody? No idea? All right, the reason is it has become an instance attribute because we manually added it here. Okay, so again, in DunderDict, you can find instance attributes. Now, in Python 3, you can have this called Dunder slots. I recommend you to look at it. Why? Because it's a bridge for Python to do a static typing. It gives you more control over your objects. Here's an example. Slots, the difference between slots, Dunder slots, and DunderDicts is that slots is defined as list. Okay? And what it enables you to do, later somebody tries to add an attribute. Here we can see an example. It fails. I recommend you using it because things break, they don't know how to fix it, they hire you again. Okay, not many people use this. And the error doesn't really tell you that much why. Okay. So slots is very useful. Now, the point of this so far is the custom objects, they either have slots, Dunder slots, or DunderDict. In both cases, we convert the attributes of objects to dictionary. We already know how to diff dictionaries. So far, so good. Now we get to another edge case, loops. Did you know that objects can point to themselves? Look at that. A list that loops to itself. Okay? So the third item of the list is the list itself. This is an example. I don't know who might use this, but somebody might. Here's another example. This is a dictionary, okay, that points to itself. So how did I find out about this? Somebody who was using deepdiff opened a ticket that deepdiff crashes on him. I was like, why? They had something like this. I don't know who might do that, but I had to fix it. And here's another example of having loops when you have the custom defined, your own user-defined object. So if you look at the dict, you see that the loop is pointing to itself. You see, it's the same object. If you look at these numbers, these are the same object. So my thought was like, how do I diff when there's loop? Okay, how many people have used deep copy? All right, so deep copy went ahead in time and saw how I did this and copied from me. Basically what happens is you grab the ID of objects. You see, like here, let's say object A, the ID is 11. You go through this, you get to the ID 11 again, and you stop there. So you keep track of ID of objects as you're doing this diffing recursively, and that's how you find out there are loops. Okay. Here's an example implementation, but I'm going to go ahead. What we learned so far, so we learned about DunderDict, Dunder slots, diff as dictionary as much as you can, and there are objects that point to themselves. There are even objects that point to another object, and that object points back to them. You can have all those cases. Now, the question is, why would you use this? I wrote it personally because I want to use it in unit tests. I had, instead of assert equal, I want to see exactly what has changed. And PyTest does that for you too, but PyTest is kind of slow. So I wrote it for that. I wrote it also when I was debugging. A lot of times I had the objects that I knew I wanted, but it was not there. I wanted to know what has changed, like the requests in Django. What exactly has changed? I have seen a lot of data scientists use this because they have big data set. They want to see what has changed. And generally, if you have code that works, you get emotional stability. That's very useful. Here basically is what you can learn from DivDiff, and I recommend you check out this. It has more details in my blog. And thank you very much for having me. Any questions?
Thank you, Sep. Unfortunately, we don't have time for Q&A, so what I encourage you is to approach the speaker in the hallway or to open an open space and invite him. Thank you, Sep.